Good morning, girls. It's not Wednesday or Thursday. It's Friday. I have a good reason for not posting yesterday, and that was that my roommate, the insane person that he is, thought it would be a good idea to go walk for about 40 kilometers or something. And we started out at like 8 in the evening, and then we got home at around like half an hour past midnight. And so I was very tired, and that's the reason why I didn't post yesterday. And the day before that, it was, I don't know, I was just feeling a little weird, and it was, I don't know, a little strange that I haven't heard from you guys. But I've heard from Johanna now, and I know she's alright, at least physically. So I'm gonna do this now. Just a little introduction. But today I thought I would talk about the neurons and how nerve cells work in general, and a little bit more. I'll think of something when I get there. The nerve cell. I drew a picture. Basically, this is what a nerve cell looks like. You have the dendrites, which are up here. I think they're called dendrites. Dendrites, it comes from tree. It's like tree branches that reach out. Then you have the body of the cell, and then you have the center, the core, nucleus, and then you have the axon that goes as very long. It's like a tail. And to show you a little bit more about how it works, this is a synapse. This is where the information that goes through nerve cells get transferred. And if you look at this little enhancement I did here, it basically works like this. You have information from that synapse terminal, or axon terminal. At the end of the tail there's an axon terminal, which sends the information into little bubbles, and the bubbles then go towards the edge, and then they jump across to the dendrite receptor, the receptor on the dendrites, and then it goes into the body, and then it gets charged up and eventually released into the axon, like so. Inside the axon there's this is the channel that the energy goes through, and that is sodium and potassium, or natrium and calcium, which we call it here in Sweden. And natrium basically goes into the channel before the action potential, that is to say the little wave of energy, and it like makes way, it pulls it forward, and then the potassium comes in afterwards and like soothes the axon, pushes it from the back. So the so it goes from here, and then it ends up here, which is basically just oh wow, this was difficult. It's basically just this place, but you can see right here. It's basically just the end of a synapse, because this is an axon and this is also an axon. So basically the nerve system is worked up like this, that the energy goes through here, it comes, and then it goes, wait, this direction is difficult, down into the nerve cell, and then it goes out through the axon. And you know, there are more axons attached to each of these little protrusions onto the cell of the body. The body of the cell, I was just showing this because this is how it usually looks. But there are lots of axons here and here and here, you know, on every little bit of this thing. And that is more or less how a nerve cell works. Yeah, it's not well, it's quite interesting, I think, but that didn't take as long as I thought it would take. So let's talk about some other stuff about the brain. Inside your brain, I don't know if I did this yesterday, but you have the limbic system. Like I showed you, it's basically this little loop-de-loop here. But two things that are really important to the brain are not in the limbic system, and that is the thalamus, which I've already talked a lot about, and the basal ganglia. And the thalamus is, like I said, like a switchboard that is all information goes through there, and then it's spread out into the brain, or information goes through there and is processed. What's interesting about the basal ganglia is that they actually work together with the thalamus. Sorry, my brain is a little bit slow, but it works together with the thalamus, and the basal ganglia is basically in control of task switching. So that is more like a switchboard than the thalamus. But if you are writing something on your computer and then you start, I don't know, or just you stop writing, it's the basal ganglia that tells your brain to switch tasks. I mean, if you write something and then you start drawing, that's a different task. So, no, maybe it's not. But let me say, if you're drinking something and then you start eating, that's a different task. If you ride your bike and then you hop off your bike and start walking, that is a different task. And that is handled by the basal ganglia. And I don't know, I think that's pretty cool that the brain has that sort of well, it does that. I mean, it would be strange if it couldn't do that, but I think it's pretty cool actually, because you don't actually think about this, but everything I've talked about right now is happening inside your brain. When you're watching this video, your eyes are absorbing the information. It goes through the thalamus back to your occipital lobe and then up to the parietal lobe, where it's processed together with the sound of my voice, and you get this sync between my lips and the voice that you hear. And then when you, I don't know, when you think about what I've said, you're using your frontal cortex, prefrontal cortex, and when you move about, you're using your, if you pick up a pen to write something down that I've just said, you're using your premotor cortex, and if you move about, you're using both your cerebellum, which is basically, like I said, it makes corrections, and if you and you also use everything else, like your senses, to see where you are and stuff. And all of this happens because of these guys. Actually, another thing that's quite interesting is that the brain axons, the end of the nerve cell, the little tail to the nerve cell, can actually be really long. We have an axon that goes from our the connection to on our hips all the way through your legs down to the foot, and that is one axon. It's that long. It has to go all the way down to your foot. I'm not sure what it's for, but you can have that long axons, and the white matter that is in your brain is basically just axons. You have grey matter and you have white matter in your brain, and the grey matter is the body of the cells, the brain cells, and everything else. You know, this part looks a little bit grey, but this part is usually enhanced, not enhanced, but strengthened with a fat called myelin, or it's kind of glue and fat at the same time, and that is white. So everything that's white in the brain is our axons. And you have these, wait, let me draw a picture. Okay, so crudely drawn, this is a brain from the top, from top down, and you have inside the brain, you have these little white, it's kind of shaped like an H, but it goes from the back of the brain to the front of the brain, and it goes between the different sides of the brain, hemispheres, that's what I wanted. It goes between the hemispheres and it goes back to front, and that is basically just a superhighway for information, because like I said, it's the axons that process the information, and it's the axons that give the information, like so. It comes out here and then it goes whoop, like that, and this part of the brain is basically superhighway for information, so it can send information back to front really, really quickly. And that is basically how the brain works. It sends information back and forth really, really quickly, and you know, that's how it gets to every place that it needs to be, fast. I don't know. I think I've actually done a lot about this now, so I don't think I'm going to talk more about the brain. I think you got the basics, and if there's anything you didn't understand about my explanations, I'll clarify them next time if you do a video. But Johanna promised she would do a video on Saturday, because she's been really busy with her job, so I hope she'll be alright, and I'll see her then. And Adrian, I don't know where you are, but I've tried adding you both on Facebook, so I guess I'll see you later. Until then, don't forget to be awesome.